Okay, geometry students, in this video we will be studying something called polyhedrons, okay? Polyhedrons. So obviously your heading for today will be, well actually I forgot to write your heading, so your heading for today will be polyhedrons. And actually a lot of books say it's polyhedra for plural, okay? So either way, we'll call them polyhedrons, we'll call them polyhedra, whatever. But nonetheless, your heading for today is polyhedrons or polyhedra lesson 12.1. And always include today's date, guys. That way your notes are organized. You can always look back and see certain things on different dates, okay? Alright, now, we'll be covering a lot of terms and definitions today. So please take really good notes. Throughout this chapter, when a problem or a theorem uses certain words, you need to know what it is referring to, okay? So this lesson is really the foundation for the rest of the lessons in this chapter. So take really good notes. Make sure you're thorough with your notes so that you know what these different terms mean. Let's start off by looking at some definitions. Now, some of these will be word definitions, of course. When I say word definitions, those are ones you'll have to memorize and be responsible for in a test or a quiz, and others will not be, okay? So, first of all, this is one that you need to be responsible for. So go ahead and copy this in your notes, and this is one that I will put on a test or a quiz. A polyhedron is a solid that is formed by polygons. A solid that is formed by polygons. Please copy that down. A polyhedron is a solid that is formed by polygons. Now, let me give you an example of what a polyhedron is, and also what a polyhedron is not, okay? It's important that you see both of these, alright? So, here we go. First of all, if you're able to sketch a box in your notes, if you have the skills to do that, please sketch a box in your notes, okay? Now, if you'll notice something about all of the sides or faces of this polyhedron, they're all polygons. For example, this the top of the box here is a rectangle, the side is a rectangle, the front is a rectangle, the left side is a rectangle, the bottom is a rectangle, and the back side is a rectangle. Well, rectangles are polygons. So do you see what I'm saying? All of these sides or faces, whatever you want to call them, are a polygon, okay? They're all polygons. So basically what you have is this for the top, you have this for the bottom, okay? For the side, you would have this rectangle right here. For this side here, you would have this rectangle here. And then, of course, the back and the front are rectangles. So, guys, if every face or if every side of the solid is a polygon, and of course, what is a polygon? Well, guys, you should know what a polygon is. There are convex and concave polygons. We've learned that, okay? This would be a polygon. Anything that has these sides like this, that's a polygon, okay? So, a solid that is made up of polygons is a polyhedron. So it might help you to understand this a little better if I show you what a polyhedron is not. This would not be a polyhedron, and here's why. It is not made up of polygons. For example, this is a curved side or a curved face right here. Well, that's not a polygon, that's a circle. A circle is not a polygon. This is a circle. A circle is not a polygon. How about the side of this can or the side of this cylinder? It's not a straight polygon, it's curved. It curves as it goes around the can, okay? So this would not be a polyhedron. A polyhedron must be formed by polygons. A polygon could be a triangle, a quadrilateral, a pentagon, a hexagon, heptagon, octagon. What is a nanogon? Nanogon is I think is a 9-side. Decagon's a 10-side. So it must be made up of polygons. for it to be a polyhedron, okay? Let this sink in, take good notes, and let's continue on. Now, let's take a look at some parts of a polyhedron. I'm not going to make you memorize the word definitions, but you definitely need to know what parts of a polyhedron these terms refer to. So when I say, look at the vertex, look at the face, look at the edge, you will know what I'm talking about, okay? So to the best of your ability, go ahead and draw this pyramid in your notes to the best of your ability, okay? Now this is a polyhedron because you have a front side right here, it's a triangle. You have a left side right here, it's a triangle. You have a back side, it's a triangle. And you have a left side over here. Here, it's a triangle. Then the bottom side is either a square or a rectangle, okay? So this solid is made up of all polygons, so it's definitely a polyhedron. So go ahead and try to copy that in your notes the best that you can. Now remember, you're welcome to write these words down. I encourage you to do that, but you are not responsible to memorize this, okay? See this triangular polygon right here? That is called a face. See this triangular front part right here? This triangular polygon? That is called a face. This back triangle over here is called a face. This base that's either a square or a rectangle is called a face. Do you understand what a face is? Each polygon of the polyhedron is called a face. Okay? Take good notes on that. Pause the video if you need to. And we're going to continue on. Now, all line segments are called an edge. So this is an edge. 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 This is right here. This is right here. This is right here. Every line segments that form a polygon is called an edge. And of course, all of these line segments form a polygon because every face has to be a polygon because we have a polyhedron. So each line segment is going to be an edge. Okay? Make sure you take notes. Make sure you make note. Excuse me for yawning. I'm sorry, guys. Make sure that you make note of this. Take really good notes. Pause the video if you need to. I'm going to continue on. Now, the point where three or more edges should be plural right here. The point where three or more edges intersect is called a vertex. So, just using slang, you can just say every little pointy edge on a polyhedron is called a vertex. All of these are called vertices. Vertices is plural for vertex. So do you see what a vertex is? It's the point where three or more edges intersect. Alright? And of course an edge is a line. So I have one line here, and one line here. They're all intersecting here. That is a vertex, okay? For this top point up here, I have a line going up, and a line here going up, and a line here going up, and a line here going up. So that's a point where, remember, it's three or more edges. So I've got four edges that intersect right here. That's a vertex. So whenever you have three or more edges intersecting, you call that a vertex. Okay? Alright, now let's look at a set of problems that will help review what we just learned. But more importantly, it will help you see a pattern that will lead to a theorem, okay? So in your books, you're welcome to just write in your notes if you want to. Page 587, example number 1. You do not need to turn in your books unless you want to. That's totally up to you. But I would definitely, instead of trying to copy all of these figures in your notes, all of these solids, I would just put this in your notes, page 587, example number 1. And then let's just talk about this and kind of work these out together. Let's let's start with letter A. We're going to count the faces, the vertices, and the edges. So here we go. The faces would be, well, there's a triangular side here, triangular side here, triangular side here, and then a base that it's setting on a side on the bottom. So it looks like four faces to me. Alright? Looks like four faces to me. Vertices, what we got? 1, 2, 3, 4. So we have four vertices. Edges. Well, edges are the line segments. So 1, 2, 3, 4, 5, 6. So we have 6 edges. So 4 faces, 4 vertices, and 6 edges. Okay? There it is. 4 faces, 4 vertices, and 6 edges. Alright? Let's take a look at letter B. Alright, let's first of all find the faces. We have a triangular face here, triangular face here, triangular face here, and a triangular face here. That's 4. But there's also a base that is setting on that you can't see, okay? That bottom side would be the 5th side. So I'm seeing 5 faces. Now let's find the vertices, okay? Well, let's see. 1, 2, 3, 4, 5. 5 vertices. Now how about the edges? Well, we got 1, 2, 3, 4, 5, 6, 7, 8. So 8 edges. Okay? So let's see if that's right. 5 faces, 5 vertices, and 8 edges. Okay? That is correct. And now let's take a look at letter C. Let's find the faces. Well, got a triangle here, 1 here, triangular face here, 1 here, 1 here. That's 5. And then the base that's setting on would be 6. So it looks like 6 faces to me. Vertices, well, I got 1, 2, 3, 4, 5, 6. So I have 6 vertices. And I should have 10 edges. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 edges. Alright? Let's see if that's correct. There we go. Okay? So students, hopefully you're understanding this and getting this. If you are, that's a good job, okay? If not, you don't have to go back and watch this again, but you should be able to look at a polyhedron and tell me how many faces, vertices, and edges that each polyhedron has. Now, I told you guys we were doing this set of problems right here to review, but also to help us see a pattern. Sorry about that. To see a pattern that will lead to a theorem. Okay? So, taking a look at this right here. Let's see if we can figure out the pattern. We have 4 faces, 4 vertices. Now right away you're saying, oh, Mr. Earhart, I see the pattern. The faces will always equal the vertices. That is not it, and that is not true. Now I know in these 3 problems, the faces always equal the vertices, but that is not always true. Okay? So no, that's not the pattern. Here's the pattern. Add the faces and vertices together and you get 8. Add the faces and vertices together, we get 10. Add the faces and vertices together, we get 12. Then look how many edges you had. 6. That's 2 less than 8. How many edges over here? 8. That's 2 less than 10. Okay? How many edges over here? 10. That's 2 less than 12. So what I'm trying to show you is when you have a polyhedron in which you add up all of the faces and all the vertices, it'll always be 2 more than the edges. So if you know how many faces and vertices you have, you can always add them together, then subtract 2, and you will see how many edges we have. Now, if I said that quickly, and you're trying to write stuff down quickly, don't worry about doing that. We're gonna write that down in a second, okay? But this pattern that I just showed you, where the sum, that's when you add the sum of the faces and vertices, is 2 more than the edges. That pattern leads us to a theorem, okay? And here it is. Now listen to me. Copy this in your notes, please. Put you are not responsible for this on a test or a quiz. Okay? So I will not put this on a test or a quiz. But copy this down, please. This is called Euler's Theorem, okay? And he's the guy that proved this, okay? He proved this. And this also, his first name was Leonard. And he also we also learned more about Euler's numbers. And I believe it's combinations, permutations, binomial expansion. If I remember correctly, I'm drawing a blank on that, and it seems like we also used Euler and some triangle things. But anyways, you'll get all that in pre-cal next year if you take that next year. But copy this down, please. The number of faces, vertices, and edges of polyhedrons related by this right here, and that's what I just taught you. If you take the faces and the vertices and add them together, then the edges will always be 2 less, so you have to add 2 to the edges to make it equal the sum of the faces and vertices, okay? So that's what this formula says. This formula says the exact same thing that I showed you 2 pages ago, where I said to you, the sum of the faces and vertices is 2 more than the edges, okay? So because it's 2 more, we have to add 2 to the edges. So if you have 5 faces and you have 5 vertices, then you would have 8 edges, 2 less. So you add 2 just to make both sides equal. But this is a formula, so you have to have an equal sign here. So in order to make both sides equal, you add 2 to the left side to the edges, okay? But this formula here is, like I said, I'm not going to make you memorize this, but the formula is important for you to learn. You need to know this formula. F plus V equals E plus 2, okay? Alright, now, let's continue on. Let's apply this theorem to a problem, okay? Let's apply this theorem to a problem. So here we go. Now again, you're welcome to turn your books. I have no problem with that. You're also welcome to just write this down in your notes and then take notes on the problem, okay? Totally up to you. But definitely put this in your notes no matter what, so that you know where the problem came from. And if you'll turn to that page if you want to, you'll see it says a soccer ball has 32 faces. So we know how many faces it has. 20 of them are regular hexagons. 12 of them are regular pentagons. Okay? How many vertices does it have? Alright, now, let's first of all think about our formula right here. Copy that down, okay? F plus V equals E plus 2. Now, the question is, how many vertices does the soccer ball have? So I know I'm looking for V, so I'm going to leave V alone. V is V. Well, I know I have 32 faces. They already told me that. So for F, I'm going to put 32, alright? And of course for 2, I'm just going to put 2. Now students, all that I have to do is find out how many edges I have. That's line segments on the ball. And then I can find the vertices. That sounds like a insurmountable task. But if you'll think about it for a second, if all of these hexagons are connected, like here's the next one here. And so on and so forth. What I want to show you is this. Now please watch this. If you listen, I will explain this very well, okay? Notice every hexagon or pentagon, one side of one is going to connect to one side of another. See it? Right here. So here's what I said to myself. I said, okay, hold it. That means every time I have a side of one polygon and another polygon, they're going to form an edge right here. Let me show you again. Where these two polygons connect, right here, they're sharing a side. That's called an edge. That's an edge right there. So I know I've got 20 hexagons. So I know every hexagon has 6 sides. So I'm going to take 20 times 6. Plus, I have how many pentagons? 12. And every pentagon has how many sides? 5. So I I have 180 total sides. So you would think you have 180 edges, but hold it. Every single time one side from a polygon, every time an edge was formed, it took two sides of two polygons. Okay, here's another example right over here. Okay, look, this edge that was formed right here was formed by how many polygons? 2, 1, 2. So every single edge that's formed really took a side from each polygon. So what that means is you're going to have to take this and divide it by 2, because if there's 180 sides, listen to me, every 2 sides gives you an edge. So I cut this in half, and that gives me 90. That's how many edges there are. Let me say it again. Every 2 sides of a polygon forms one edge. So if I have 180 sides, divide that by 2, because every 2 sides forms one edge. So 180 divided by 2 is 90. So now I know I have 90 edges. And just like that, now I can find the vertices. 32 plus v equals 92. Now bring the 32 over, make it a negative 32. And v equals 60. V equals 60. Okay, so students, I can find the number of vertices by using this formula when I know the number of faces or edges, or you can find edges if you know faces, and vertices, you can find faces if you know vertices and edges. Okay, this formula here is really helpful to use. Alright, pretty tough problem to see on your own, but hopefully the explanation made sense. Okay, alright, that's it. I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.